Dear students, in the last lecture we have discussed the meaning of dummy variables and its two implications, namely the change in slope and intercept and stability of the regression model. So in this particular lecture we shall discuss the remaining two applications of dummy variable. The first one is deseasonality and the other one is interaction effect using dummy variables. So before discussing the deseasonality of the variable, first of all I like to introduce the concept of variable trap. This is a very small concept but yet a very important concept. So what is dummy variable trap? So dummy variable trap arises when we include as many dummy variables in the model as there are total number of categories. So if there are two categories, if you include two dummy variables, then there will be a dummy variable trap. So in order to explain it, let us formulate consumption function. This we have already discussed in the previous lecture. So in the consumption function, we want to analyze the impact of war on consumption. So we have two categories, war and peacetime. So if we introduced two dummy variable for these two categories, then there will be problem of dummy variable trap. So in this situation, there will be perfect multi-collinearity between two dummy variables. So later I will explain to you how there will be multi-collinearity between two dummy variables. So first of all, consider the following model. This is your consumption function. Ct is equal to alpha plus beta 1 yt plus beta 2 d1 plus beta 3 d2 plus ut. So here d1 and d2 are two dummy variables where y is the income and c is the consumption. d1, what is d1? d1 will have value 1 when there is peacetime and it will have value 0 if there is war. d2, it will have value 1 if there is war and it will have value 0 if there is peacetime. So we have incorporated peace in both variable d1 and d2, and we have also incorporated war in these two variable d1 and d2. So basically there was two categories, peace and war, and we have included two dummy variables for peace and war, d1 and d2. So number of dummy variables are equal to number of categories. So this will lead to a perfect multi-collinearity between d1 and d2, and this will be a dummy variable trap. For example, suppose we have year 2005, 10, 15 and 18, and this we have consumption in crores 100, 152, 142 and 175. So D2 which means which is associated with wartime. So suppose in 2005 there was war, so we have 1 against 2005. In 2010 there was no war, so we have 0. In 2015 there was war, we have 1. And 18 there is no war, so we have 0. Similarly in peace, this is another variable for the same two categories. So 2005 we have war, so peacetime against peacetime there will be 0, and in 10 there was peacetime, so we have 1. There was war and we have 0, and in 18 there was peacetime and here we have 1. So for peacetime we have all the values 1, and for war we have all the values 0. So you can clearly see that these two dummy variables are perfectly collinear. Here we have 1, here we have 0, here we have 0, here we have 1, here we have 1, here we have 0, 0 and 1. So there is perfect correlation between these two variables. So there will be the problem of multi-collinearity in case there is dummy variable trap. So what is the solution to the dummy variable trap? So solution to the dummy variable trap is that if there are two categories, then we must introduce only one dummy variable. Generally, the rule to introduce dummy variable is that if there are n categories, then number of dummy variables should be n minus 1, or if it is very necessary to include as many dummy variable as there are number of categories, then we should omit intercept from the model. We should not include intercept. We should define model without intercept if you want to include two dummy variables for two categories. So this is alternative to this rule. So in this model we have omitted alpha. So this is another method of solving the problem of dummy variable trap. So now we can have a look at the problem of the application related to deseasonality. So what is deseasonality, and what is, first of all, what is seasonality? Most of the economic time series based on monthly and quarterly data, they exhibit seasonal pattern, that is there will be seasonal movement. For example, sale at departmental store during festival holidays, agriculture production, it also have various seasons, demand for ice cream and soft drinks during summers. So there will be seasonal variations. During summers there will be more demand for ice cream and soft drink, and during winters there will be less demand for ice cream and soft drinks. So if this trend is applicable for 1 year, then this trend will also be applicable for another year. So this trend will be repeated for every year. So in this way there will be seasonality. For all winters there will be less demand, and for all summers there will be high demand for ice cream and soft drinks. So this is known as seasonality. And before incorporating such seasonal variables in empirical estimation, we have to eliminate the seasonal effects from such variables, and this is known as deseasonalization. So time series which we obtain from such process is known as deseasonalized time series. So there are many methods of deseasonalization, and one of the method it uses dummy variables to remove the seasonal effects. For example, if you have monthly data, then for 12 months you have 12 categories, so you need to include only 11 dummy variables. For quarterly data, so there are 4 quarters, means there are 4 categories, and you need to include only 3 dummy variables for those 4 categories. So note that we are including one less dummy variable for total number of categories to avoid dummy variable. So now let us assume we have following model where YT is your sales, and sales basically it is a quarterly data. So you have 4 quarters, and each quarter will have 3 months. So for 4 categories you will have 3 dummies, D1, D2 and D3, and of course you will have a intercept. So Y is a sale of product. So if the value of sale belongs to first quarter, then D1 will be equal to 1, otherwise it will be equal to 0. If sale belongs to second quarter, then D2 will be equal to 1, otherwise 0. If sale belongs to third quarter, then value of D3 will be equal to 1, and otherwise it will be equal to 0, and impact of fourth quarter will be captured by intercept. So it is taken as base. So there are 4 cases. In case 1, the first quarter D1 is equal to 1 and other D2 and D3 are equal to 0. So the model will be equal to YT plus beta 2 plus UT. And in case of for second quarter, the variable d2 will have value 1 and d1 and d3 will be equal to 0. So put the value of d1 0, d2 1 and d3 0. So you will have this model. Similarly for third case, in case of third quarter, d1 d2 will be equal to 0 and d3, since it is it represents the third quarter, so its value is equal to 1. So alpha beta 2 d1 0, d2 0 and d1 0. So your model for third quarter will be this. So alternatively, the above deseasonalized process can also be solved as follows. So in this case you can specify the following model. So in this case you are specifying 4 dummies for 4 categories for 4 quarters: beta 2 d1, beta 3 d2, beta 4 d3 and beta 5 d4. Clearly see that we don't have intercept here. We have omitted the value of intercept. So you can include 4 dummies for 4 categories, but you have to omit the value of alpha in order to avoid the problem of dummy variable trap or multicollinearity between dummy variables. So this process using this model, this particular model, is known as pure deseasonalization, but it is always better to follow the earlier procedure. For n categories there are n-1 dummy variables. So this is known as deseasonalization. The next application we have interaction effect using dummy variable. So in interaction effect basically is the product of 2 qualitative variables. Qualitative variable is 2 dummy variables, is the product of 2 dummy variables. That is, it is not always true that the dummy variables are always additive. They can also be multiplicative in nature. So the following model represent a additive nature of dummy variables. So yt here is salary, x is the education level, d1 here is, d1 represent the person is female, d2 represent the person is black or white. So d1 will have value 1 when the person is female and 0 if the person is male. D2 will have value 1 if the person is black and D2 is equal to 0 if the person is white. So here again the variables are, dummy variables are additive in nature. So it means D1, which is a gender dummy, which is a gender which is associated with a male or female, gender dummy is constant across the categories of race. Means if the mean salary of female person is less than the male person, then it is irrespective of the fact that whether that person is black or white. Similarly, D2 is the race dummy and it is also constant across the gender dummies. It means if the salary of black person is lower than the white person, then it is irrespective of their genders, whether they are, he or she can be male or female. So this implies that two categories are independent of each other and do not have exert any influence on each other. But in reality, there may be difference between the salaries of black female than white female, then black male than black female, black male than white male, white female than white male, and so on, because it is believed that females have always lesser salary than males and black people also have lesser salary than white. So the gender and the race variables can interact with each other. So in order to incorporate these effects in the model, so we will define the following model where yt is again the salary, xt is the education, d1 is the person being male or female, d2 is the person being black or white, and d2 is represent that the person is black and female. Beta 2 is showing that the person is female. Beta 3 is showing the person is black male, is black. Beta 4 is the differential of being black female. Both are available here. D1 is 1, D2 is 1, means person is female and person is black. So this is the possibility of black female. So average salary of black female will be equal to D1 is equal to 1 if the person is female, and beta 3 will also be equal to, it will also be there since D2 is equal to 2, the female is black and the both are equal to 1, so beta 4 will also be there. Then average salary of white female. White female means that this beta 3 will not be there since it represents black. So beta 2, only beta 2 will be there. Then average salary of black male means there will be only black person. The person is on black and he is male. So it means beta 2 will be equal to 0 and so on. And here finally, here this is our base model where the person is white and male. Beta 2 is equal to 0, beta 3 is equal to 0, and this is also equal to 0. So you have basic model yt is equal to alpha plus beta 1 xt. So this is your base model for white male. So it may be noted here that all differential, if all the differential effects in this model, in the model 2, in this model 2, beta 2, beta 3, beta 4 are turned out to be negative, if all the values are negative, which means that average salary of black female will be less than all the categories, that the person is female and moreover she is also black, so it will have minimum salary than all the categories if all these coefficients are negative. So in this way you can show the interaction effect of dummy variables, which is a very important and realistic concept. So thanks for